All right. So I'm pleased to be here today. It's been a busy week. I know it's been a busy week for everybody else. It's graduation season, so people may not be here. But if you if you don't catch everything, there will be a recording on YouTube posted shortly after the talk. Our topic tonight, broken windows and tracer bullets, over 25 years of pragmatic wisdom. And again, I'm Gary Ray. I'm a senior director of engineering for a company called Caseworthy. We build case management and analytic software in the social services space. And the slides, when I update them after the talk, will be available at the link on the screen right now. I will have a little bit of a audience participation or homework assignment at the end, and so I won't update the main branch of the repository until after we get a little bit more information and I update the last slide. So give it a couple of days, and then I'll post a link in the meetup chat when the slides are up. So diving in, recently I saw a sticker. So I had to go online and buy several of them, a couple for me and a couple for my wife. The sticker says, "Be patient with me. I'm from the 1900s." And I am. I transitioned from being a professional economist to being a professional developer in 1998. And I want to talk a little bit about what the environment was like in 1998. So as my career started, Yahoo was the undisputed leader in web search. Although if you were in academics or research, Alta Vista was a search engine that got a lot of traffic. In possibly one of the greatest missteps in all technology, in that late 90s period, Yahoo had an opportunity to buy Google for $1 million. The founders wanted to get out so they could finish their PhDs, and Yahoo turned them down. Instead, just licensed their search results. And we know how that's turned out. .coms in the late 90s, burning through venture capital cash just as fast as they could. Offices full of Aerons and pinball machines and ping pong tables. They were dropping millions of dollars on Super Bowl ads. Leading up to and coming out of the Y2K code crunch, concerned voices started talking about the dot-com bubble. And in fact, the dot-com market peaked on March 10th, 2000. By November of 2000, the market had completely collapsed. And the pets.com stock market, among lots of other mascots, was on the unemployment line. Even Amazon, their stock fell in that early 2000 period from 107 to $7. And through the late 90s, there was an explosion of new projects taking advantage of web and distributed computing. There were hundreds of ground-up rewrites being taken on by companies, by governments, and migrations of millions of lines of mainframe code. And in that series of projects, in the mid-90s, the Standish Group put out a report that pointed out that only 16.2% of these large software projects were successful. And that's despite, possibly because of heavyweight waterfall projects, methodologies attempting to map all the requirements and details, get all the big design up front. Coming out of that environment, there were a lot of experienced software developers who were trying to do new things. And they started in the late 90s publishing some books about that. Crystal Clear, a human-powered methodology for small teams by Alistair Cockburn. It's the Scrum development process. First paper about Scrum that I was able to find was published in 1997. Some of you may have been around to remember extreme programming, Kent Beck and others coming out of the Chrysler Corporation, where they were doing a lot of software redesign there. And out of extreme programming came ideas of pair programming and TDD and a lot of the unit testing. And this group and others, including the authors of the book we're talking about today, got together here in Utah at Snowbird in 2021 in February and actually created the Agile Manifesto, which kind of revolutionized how we think about the process and practices of doing software engineering. In 1999, in that environment, Andrew Hunt and Dave Thomas published The Pragmatic Programmer, From Journeyman to Master. And unlike the other books that were just listed, it was not presented as a systematic methodology. It wasn't telling you this is the way you operate as a team and build software. Instead, it was simply a series of tips and techniques pointed at developers to help them improve in their day-to-day work. The original book had 70 tips distributed across 8 chapters. Now, since then, since 1999, software industry has been up and down and up and down and up and down, several cycles. And in addition to that, programming languages have come and gone, tech stacks have come and gone, new JavaScript framework every couple of weeks. So in 2019, the authors got together and decided they wanted to take the things that they'd learned over the previous 20 years and do an anniversary edition. In that anniversary edition, they added one new chapter, completely new chapter, and then added 30 new tips across the entire book. Now, tonight, of those 100 tips in the book, and if you go to the meetup invite, you can get a link to the Pragmatic Programmer site where they list all 100 tips. I'm just going to highlight a few that are my favorites. And my favorites have changed over time. In fact, at the end, we'll have a slide of some honorable mentions. In times, I'd put some of those honorable mentions in that top 10. But we're going to talk about just 10 of these tips. And I promise you, it's unlikely that any of these tips are going to be new. They're going to be things that you've heard before. But I hope that you take this talk as a reminder to care about your craft, to be introspective about the work you're doing in technology. For context, I've grouped these tips across 5 questions that I hear asked over and over in my career. And the first question is, why does our code base feel like a minefield? This is, I think, the world that most developers live in. And we know that over the full life cycle of a software project, of any particular set lines of codes or modules, roughly 80% of the time spent working with that code is actually in the maintenance phase. It's working with legacy code. It's trying to keep systems alive after that first iteration has gone to market. And I don't know about you, but I've worked on several projects where the nature of the project is error pop-ups or UX little bugs, and people just close them and ignore. I've worked on projects where when you look in the browser tools, there's console errors that just get hidden. You get build warnings. Now we know if you get a build error, the build error stops your build, but you'll get systems that'll have build warnings, just pages and pages of warnings, or you'll get linter recommendations that go unheeded. So the first 2 tips that we talk about are about how do we make our working in our code not feel like a minefield. And the first tip is don't live with broken windows. And if you're not familiar with the broken windows theory, it comes from community policing. And the idea is if you've got an abandoned building and the abandoned building is at least reasonably well taken care of, there's no broken windows, the lawn is mowed, it can stay in that state indefinitely. Once some kid walks by and throws that first rock and breaks that first window, the building deteriorates almost instantly. Over the next few days, all the windows get broken, doors get knocked off their hinges, the building gets ransacked, the copper gets stolen. Our systems are much the same way. If we ignore that first few broken windows, what happens is what we've accepted as the state of the system becomes the new standard for the system. So the first tip is don't live with those broken windows. Make sure that you're fixing your bad designs, you're fixing wrong decisions, you're fixing poor code when you see them. Much like the Boy Scout rule, when you touch code, leave it better than you found it. A corollary to that is tip 65, which is refactor early and refactor often. Here in Utah, most of us, if you do garden, are probably in the process of planting your garden. I always joke with my wife that we typically have the first planting, and then everything gets frozen, and then we have the second planting, and the second planting is what works out. Fortunately, this year it looks like the first planting is going to be the good planting. But just the same as you might weed a garden, you might rearrange it, you rotate your crops. It's important to rewrite, rework, and re-architect code when it needs it, fixing the root of the problem. If you do that, we can avoid or minimize the amount of time we spend working on those super fragile systems where every change everyone's scared to make, that every change results in a new bug or unexpected behavior somewhere else. The next question we get that I've heard quite frequently throughout my career is, why on earth do we keep rewriting the same thing? Why do I end up doing the same kinds of functions, the same kinds of modules, the same kinds of APIs over and over and over in our system? Now, some of that may be you've just changed companies, you changed careers. You may have to write the same thing for a different company. But when you're working on a single project, why is it that we keep having to rewrite the same thing? So some tips from the Pragmatic Programmer that deal with this are first, work to eliminate effects between unrelated things. Now, this is a tip that, if I recall, got a lot of revision between the first edition and the second edition. In the first edition, it was called Design for Orthogonality. That's a funny math word that essentially means two lines that intersect at 90 degrees. So if you change something on one axis, nothing changes on the other axis. And our software should be similar, packaged in small, cohesive, decoupled units where a change in that unit does not force changes in other units. That has a lot of advantages. First of all, we have localized changes. Again, you change it in one place, you don't have to change it in a lot of others. Orthogonal or modules and systems that have minimal related effects or effects on unrelated things, modules that are self-contained, they promote reuse. And modules like that also reduce risk. Problems tend to be isolated. It tends to be really easy if you've got self-contained and independent units. It becomes much easier to troubleshoot those units, identify where those problems arose. And there's a really subtle benefit from having orthogonal or very decoupled and cohesive units. And that is a combinatoric effect. If you've got two modules or two APIs, and they're completely independent, and one has 9 functions or M functions, and the other has 3 functions, if they're orthogonal, they give you the opportunity to have a combinatory effect when you use them together. You end up with 27 possibilities of how you can combine the functionality of those units. If you've got code that's got an overlap that's not orthogonal, first of all, you end up with that intersection of the behavior in both modules, reducing the ability to combine those modules. And even worse, if they are related in unexpected ways or have differing or unexpected differences in the internal behavior, when you combine those, you can end up with really hard bugs to track down because one API or one module treats a piece of information in one way and the other module or API treats it in a different way. And it can be really hard to track down why sometimes you get one result and sometimes you get another result. The other tip that helps us keep from rewriting the same thing is probably one of, if not the most famous tip from the book. And some sources attribute this tip to the Pragmatic Programmer, and that's dry. Don't repeat yourself. Every piece of knowledge must have a single, unambiguous, and authoritative representation within the system. In the second edition, the authors talk about this section being one that they actually spent the most time rewriting and changing. And we're going to talk a little bit about code repetition, but they said they point out, and we'll highlight in this example, one of the ways that people kind of misunderstood this when it first came out. And then also, don't repeat yourself goes well beyond just don't cut and paste code. So first is, when we're worried about not repeating ourselves again, the idea is to have each piece of knowledge having an unambiguous and authoritative source of truth for what the behavior is or what the representation is. So here's some pseudocode, and this pseudocode is directly from the book. And we have two functions. We have validate age, that takes in a value, and validate quantity. And there are two other functions, one that validates the type and one that validates the minimum integer allowed. I've run code similar to this through some linters or systems like SonarQube, and they're very good at pointing out that this appears to be duplicate code. But a key thing to note is, yes, the internal implementation of these algorithms may be currently the same, but they are capturing fundamentally different knowledge. And age is not a quantity. Sometimes you'll hear in tips and talks about software design, you'll hear about primitive obsession. You know, you'll have classes where everything's a string or everything's an integer, everything's a primitive type. If you think about age being a type, age is a piece of knowledge you need to know about. Quantity being a type, a piece of knowledge that you need to know about. You recognize that these may not necessarily be duplicates. They actually hold different ideas. And after we release our code and we get our first set of feedback, we might find that there are two very different implementations inside validate age and validate quantity. Now, we've still abstracted out functions for validate type and validate range, but the implementation in these functions represent the business rules, the knowledge that we need to capture. Validate age is now validating, in the US that somebody is of the age of majority or an adult. Just like Lego, although I think Lego just changed the rule, you can't play with Lego after you're 100. It goes age 8 to 100 or whatever. And if we decide that our system needs to allow somebody to be 120, we can change that in one place. Validate quantity. We may have a particular rule about what quantity is allowable. We can't have a zero quantity. We can't have a negative quantity. We can't have a quantity greater than 500. But we've captured that in this code. The fact that those started out with identical representations does not necessarily mean that those were duplicates. This is even more important as we talk about implementations across microsystems or microservice and API development. If you've got a microservice or a really targeted API, you may have a function in that microservice that is specific to that domain that's identical to another implementation that's specific to another domain. Those are not necessarily duplications. But even more than dry, don't repeat yourself in the code, we need to recognize that when we talk about having a single and unambiguous authoritative representation for knowledge across a system, that your team is a system. Your organization is a system. Design decisions, architectural organizational decisions, documentation, all of those are things that if we have a single point of reference and we're not repeating ourselves, our lives get better. I'll tell you a little story recently from my career. We have a system where as the data goes through various ETL pipelines, the ID that represents certain entities change as they get imported to into one data store and then transformed and imported into another data store. And I probably sat through 7, 8, maybe more meetings as we talked about making modifications to the system where that piece of knowledge, that the IDs of the data as it passed through the system changes was a key piece of information to make an appropriate design decision. But people kept forgetting. And I kept having to say over and over in meetings, hey, this is how the data changes as it goes through this data pipeline. And finally, I took to heart advice that Scott Hanselman put out on his blog in the early 2000s. You have a finite number of keystrokes left in your hands before you die. Are you spending them well? Are you wasting them? Every time somebody asks me a question in a Teams chat or an IM, and I quickly type out an answer, that piece of knowledge, while it may be in the archive in Teams, that piece of knowledge is only useful to me and to the person I responded to. Somebody sends me a text, somebody sends me an email. If I just shoot an email back, it's only useful to that person. A much, much better idea is to use our shared data stores, our shared knowledge repositories, our wikis, Confluence page, forums. Write up your answer, post it to, if it's internal, if it's business confidential, post it to your internal wiki or your Confluence page. If it's an idea that you've got that's more important than that, post it on what is it, dev.to, I forgot what the dev site is, or post it on Medium, or post it on a blog. Write it up in a way that it's permanent, and then point people to that source. That allows us to capture that knowledge, share that knowledge, take advantage of those limited keystrokes you have left in your life. But worse than rewriting the same thing, I think, is building the wrong thing. And I've gone down this road a couple of times in my career as well. Few things are as demoralizing to a developer or to a development team as pouring months into a feature that then gets released and people hate it or people never use it. And in the world we have today, with so much traceability and metrics and visibility into our code, there's no reason for us not to know how our systems are being used. There's 2 tips that the authors released about how do we avoid building the wrong thing. The first tip is prototype to learn. It's tip 21. The value of prototyping is really not in the code that we write. It's not in that first early foray into solving the problem. It's in the lessons we learn. And the tip use tracer bullets allows us to hone in on our target as quickly. Note, both of these tips at their core, are about increasing the speed of your feedback loops. Now remember, when you prototype, the whole intent is, can I learn something about the way my system should behave or the way my technology works? What can I learn as fast as possible? And then throw away and do the production targeted implementation. Tracer bullets, if you're not familiar with tracer bullets, it's a military technology. You load a machine gun with bullets where every fifth or every seventh or every 10th bullet is phosphorescent. And so as you fire your bullets, you can see the actual path of every fifth or seventh or 10th bullet as it goes towards the target. And it allows you to start firing, and then as you watch that visible light trace go with the bullets, you can very quickly refine your targeting and point at what you're trying to hit. In the software world, the analogous behavior to that is working in very, very small increments. Being very intentional about your iterative development and getting those increments in front of your target audience as fast as possible. The interesting thing to me about these two tips is we've had, as a user group now, several talks about AI and using generative AI in our workflows. I think these two tips are places where AI is a huge, huge multiplier for the effort that we make in building and designing systems. Interestingly enough, I mean, again, the book came out, its 20th anniversary was 2019, and that was really before this massive leap we've had in LLMs and code generation. So yeah, we can sit down and I can write out a few instructions and get my Claude engine or my Open API or OpenAI engine to generate a bunch of code, generate a UI. I can do that. And it works very quickly. I can get that in front of my user or my customer very quickly. And that is fantastic. Again, that quicker feedback loop is always going to be advantageous. But, and this is a huge but, there is a real risk as you lean further and further into AI for prototyping and for doing tracer bullets, for doing that early development to learn not only about the system, but learn about what your customers want, to forget that learning is the key thing. That the key benefit of these two tips is the knowledge that you and your team and your company develop and gather from these early and quick rotations of your code. So by all means, lean into AI. We at my company have an initiative to roll out various AI coding tools to all the developers and really want to mentor and coach the developers to get better and better and more effective at those. But the learning is the key. And we'll come back to that idea that learning is key. So let's move up our career ladder a little bit. Most of what we've talked about so far has been answers to questions about the code that we write and the systems that we build. I want to talk about why does nothing ever get fixed around here? And that's actually a very, very different question. Yeah, code can be difficult to fix. It can be legacy code, and some of those early tips about refactoring and not repeating ourselves make a big difference in there. But why does nothing ever get fixed is very, very often a team or an organizational problem. It's a problem focused on options, focused on trade-offs, focused on priorities. Two tips focused on why does nothing ever get fixed around here. First is provide options, don't make lame excuses. This is critical as you move from being a junior to a mid-level to a senior to a team lead to a staff engineer to an architect or to a manager. Don't be a blocker. It is so easy for individuals and teams to be blockers, to say, well, it's broken, we don't know how to fix it, or even worse than being a blocker, be a complainer. Oh, I don't know why we made these decisions, but we're stuck with them. Bring options to the table. As I mentor people that are in my organization, I tell them, please don't come to me with a problem. And in fact, don't just come to me with a problem and a solution. I want you to come to me with a problem, what you thought about as multiple solutions, and then I want to hear your reasons why you're recommending solution A as a solution to the problem. I want to see that you thought about deeply, whether it's a code problem or an organizational problem, you thought about what needs to change in order for the problem to be resolved, and can defend your choice. So yeah, bring those options to the table. In their book, Behind Closed Doors, Secrets of Great Management, Esther Derby and Johanna Rossman point out, 2 options is a trap. You feel constrained by the either or. But 3 options leads to 4. And that's happened so many times in my career. In fact, it happened over the last 2 weeks. We have a system that's got a huge problem. We need to come up with some new architecture, a new set of processes to keep our customer happy and retain a customer that is very important to our company. We started out with 2 options. Do this, do that. And we went through 2 design meetings with only those 2 options. And then, kind of in a side conversation, a 3rd option was identified. And since then, 2 other variations in just a couple of days have been pointed out. And I'm fairly confident at this point that what is now option number 5, or option number 1.3, I think, it's kind of a variation on the first option, is the direction we're going to go, and is going to be far more maintainable and far easier to implement. We'd have never gotten there had there not been the side conversation that led to that 3rd option. If we had believed that we were forced to pick between either or. One of my personal biggest tips is, if you're faced with only 2 options, take a minute, step back, try to come up with at least a 3rd. Once you come up with that 3rd, you'll find that other ideas very frequently flow from that. In that same idea, good design is easier to change than bad design. Again, we want to have iterative ideas. We want to have iterative design. And this kind of points back again to that idea of orthogonality, of systems that are loosely coupled and independent. Well-considered designs and incremental implementation lead to architectures that are evolutionary, that adapt to the changes that are pushed upon them. But again, in this very similar way to what we talked about with dry, remember that when we think about why does nothing ever get fixed around here, it's not just the technical systems. Your teams and your organizations are systems as well. So whether you're doing Scrum, or whether you're doing old school XP, whether you're doing Kanban, Lean, or some other methodology, your long-term happiness and your long-term productivity as a team is not a question of which process is best. It's a question of being able to adapt that process to your team. It means measuring outcomes, being aware that as soon as you measure something, you may have changed the incentives for the team, but you still need to measure even something as simple as how many working features have we delivered in the last sprint, quarter, whatever your time period is. Measure those outcomes, but even more importantly, do retros. Let those retros be team-led. If possible, throw your senior leaders out of retros. I'm involved in a team where I do work that's at an individual contributor level, and they don't let me in the team retro. They just remind me after every sprint almost, hey, make sure you're not blocking the work of everybody else because you have to go to meetings all the time. Make sure that your lowest level members of the team feel comfortable in expressing what they need, what they like, what they dislike, what needs to change for the team to be productive. And talking about career ladders then leads us to our last big question and our two last focus tips. And that is, why am I stuck in my career? Now, hopefully, nobody in the room and nobody online is stuck currently in your career. But I do want to ask yourself, the second edition of this book, the 20th anniversary edition of the Pragmatic Programmer, came out in 2019. So we've been a little over 5 years since this book came out. In that 5 years since this decade began, have you really had 5 years of experience? Or have you instead had 1 year of experience 5 times? That should be a question that you periodically come back to. You and you alone are responsible for your career growth. Not your boss, not your company, not your team, you. So 2 key tips from the Pragmatic Programmer. First, care about your craft. Now, software development, as much as we sometimes try to push it that way, it's not a science. As much as we try to push it to being like a licensed engineering occupation like civil engineering, it's not a licensed occupation. I don't even believe that it's best described as an art. I think art is a different idea. Art is something that's designed to elicit an emotional response. I believe software development is truly a craft, maybe most analogous to something like furniture making. It's designing and building products put in front of users designed to be functional and enjoyable to use, not just nice to look at. Software development is a craft. If you care about your craft, you will invest regularly in becoming better at your craft. And invest, I believe, really is the right term. Investing is, it's just like investing in a financial market. You need to build your portfolio as a developer. So you start with investing regularly. You have to make learning a habit. A book a month is a recommendation that comes from the Pragmatic Programmers. In fact, they actually recommend 2 books a month. They recommend that you read, Steve's eyes just got really big. Listen on Audible. They recommend reading a tech book every month, and then at least periodically reading a non-tech book. Read a non-tech, non-fiction book. In the world that I work in, I tend to read books about, again, social services, social problems. I read about homelessness, eviction, medical care. It's the world that permeates the software that I need to develop. And then read fiction books. Everything we build is for people. Learn about people. Diversify. The more different things you know, the more valuable you are. And that certainly does not, again, mean just tech. Yes, if you know Python and C Sharp, and you know AWS and Azure, and you know various flavors of SQL for SQL Server and Postgres and Oracle, those all increase your value. But soft skills become more and more important as you move up your career ladder. So make sure that as you're learning and building your portfolio, that you're diversifying not just in hard skills, but also in soft skills. Manage your risk. Do not bet the farm on the one shiny new thing. It may seem silly to say, but every even currently stable technology is going to age out. So make sure that you're kind of keeping abreast of what's happening in the world you work in. The one part of this metaphor that's a little bit tough is the buy low, sell high from investment. It's very hard to do. As anybody who initially bet on cold fusion, or bet on flash, or bet on Silverlight, all of those things are people nodding in the room. All of those things are a road that some of us may have gone down. If you put all your eggs in that basket, you've got a basket that's in trouble. So similar to diversify, by all means, dabble in these new technologies. Look at the bigger market. Try to evaluate who's behind certain pieces of technology. I'm always interested, again, in kind of the JavaScript frameworks. I worked in Angular for a while, and I worked in Vue for a while, and I worked in React, currently working in React, which is probably why I couldn't remember it. But there were other, Knockout and other frameworks in that early world. And it can be, I don't know that 10 years ago that I would have bet against Angular. And I don't think being an Angular developer right now is a bad thing. It is possible when there's a range of 10 or 12 new shiny things, it's possible for 3 or 4 of them to continue to persist and still be valuable. We'll see that in one of the next final slides here. But related to that idea, as you dabble across some technologies, make sure you are periodically reviewing and rebalancing, that you revisit tech that you may have skimmed early on or may have even discarded. Again, I went down the Angular route initially, and now the last couple of positions that I've been involved in, React has been the winner. So I've revisited that decision and retooled. When I talked about rebalancing, I wanted to point out this slide. This is top programming languages from 1970 to 1925. I personally know Fortran and COBOL programmers. I know a COBOL programmer who is working in COBOL today. Not a bad gig for him. He's probably sure he makes more than I do. But it's not a language that allows him to easily transfer his skills at this point. When I was talking about a lot of new languages, and it's possible that 3 or 4 of those things can kind of bubble to the top and stay to the top. This is a .NET meetup. I have no idea really where C# is going to be on the list in 10 years. I hope it stays near the top. I love it. I think it's a fantastic language. But I also like F sharp. I also really, really like Python, as long as I'm not getting burned by duck typing, because my brain works in strongly typed languages. But Python is great for a lot of the uses that we have. In the web world, JavaScript is fantastic. I've done enough Java that if I had to, I could jump to a Java position. It's great to be balanced across your portfolio. But remember, technology changes. Languages and tech stacks come and go. Make sure you're building the habit of learning so you don't fall behind. Now, we're coming up on the end of our time, so I'm probably not going to dive into these, but I did want to point out some of the honorable mentions out of the tips. Again, these are things that maybe a few years ago, some of them would have been in my top 10. I'll click through them really quick so it loads the page. One of the big ones is keep knowledge in plain text. And this one maybe should have been in the top 10 right now. These slides are markdown files that are built with MARP. If you're not familiar with MARP, it takes your markdown slides and big slides. It takes your markdown text and makes slides out of them. Can be HTML, can be PDF, can be PowerPoint, several different output formats. But the information is in plain text. If you keep your knowledge in plain text, this is another place where AI then becomes very, very powerful. If you point your AI at a directory full of plain text files, it can summarize, it can analyze, it can format, it can add all kinds of value. And I know that AI agents have skills or other ability to open a Word doc or open an Excel doc and generate a PDF. But if it's all in plain text, you're not burning compute. You're not burning tokens trying to get this thing to open some kind of binary or proprietary format and get the information out of it to analyze. So yeah, keep your knowledge in plain text. Achieve editor fluency. This has always been one of my favorites. Unplug your mouse. Take the batteries out of your mouse for an hour a week or for an hour a day. Learn all those keyboard shortcuts you've never knew or you've forgotten. You're far more productive with your fingers on the keyboard than you are with your fingers on the mouse. Select isn't broken is one of my favorites. If you've never encountered that, it means the engine that runs select and optimizes select in your database engine is likely not the source of your problem. Well-designed, well-supported libraries, commercial libraries, typically not where your bugs come from. If you've got a problem in your system, my rule of thumb is always assume it was my problem until I've got evidence otherwise. If it's important enough to be a global, wrap it in an API, that kind of gets to our reuse. Listen to your inner lizard is a great, it talks about your lizard brain. You know, we all over the course of our career kind of develop this sixth sense that, ooh, that hurts when I look at this piece of code, or oh, that hurts when I bump up against some organizational constraint. Listen to that. That's a signal. Put a little effort into resolving that, because if it's pinging your lizard brain, it's probably bothering other people. And finally, again, another favorite, the coding ain't done till all the tests run. Probably enough said there. So I talked about at the beginning of the talk that there was a kind of a homework assignment. And the homework assignment is this. My email is currently on the screen, gary.ray@gmail.com. And what I would like is in the next day or two, by the end of the weekend, I'm going to finalize the slides in this branch and push the branch to main. But think about the books that you've encountered or the blog that really changed your career. And just send me a quick note. Hey, I loved design patterns. Now, only send me design patterns. I guess the full title, Design Patterns, Elements of Reusable Software, I think is the full title. The Gang of Four book. Only send that to me if, one, you actually read the whole book, and two, it really did change the way you think. That's my rule. Don't send me stuff that's just because you've heard this is a great book. Send me stuff that's really made a change in your career. I've added a couple that to the bibliography that made a difference to me. Obviously, one of the biggest is the Pragmatic Programmer. It's probably one of the main reasons I'm still in tech after making that early shift in the late 90s from economics and economic research to technology. So send me those suggestions, and any suggestions I get, I will add to the bibliography, and they'll be in the slides that get posted to the meetup comments. And then finally, this is my final slide. This is, we'll open it up for some questions. And if you want to get a hold of me, first of all, again, there's the link to the repo where the slides will be posted, my email. I've finally come to terms with calling it X instead of just Twitter, but I'm at Geek Cyclist. I do have a couple of blogs. One is the agilecoder.net, and the other is Geek Cyclist. Agile Coder is tech focused. Geek Cyclist is personal focused. Unfortunately, in the position that I'm in now, a lot of the knowledge that I try to collect and share tends to be proprietary, so I'm not super active on. We can have a little discussion, or I'm willing to answer any question.
To apply, maybe try messaging one of us in Discord, because that's going to be a better way to get our attention, I think. Same with, let's see, what else? Presentation proposals, bottom right, that SLCnet, tiny URL. If you'd like to present, we would like to see a presentation proposal. And I think that's all the stuff there. Oh, nope. If you happen to know an entity interested in sponsoring, let us know. That could, get us maybe food or different prizes or something. That's that. Current sponsors, JetBrains, Health Equity, O'Reilly, and Mountain Land Technical College, which is where we are at in person, provided this space. Okay, prizes. Caleb, has anyone filled out?
I'm not actually going to worry about it. There are 4 people and we have 4 prizes. So the only thing that we have to figure out is who gets what prize.
Well, we need a good email for everybody who gets a prize, because everything has to be delivered by email. So
that's true. So we do need you to fill out the form. One of the things that some people have often said is, I don't need a JetBrains one. Now, I don't know why, because if you have one, it can add more years to it, unless it's like the all products pack or the, a couple of things like that. So assuming you don't have that, then you can get just a different product. So if you have like Writer and you want PyCharm, you can get the full version of that. So there's options. But if you don't want it, let us know that you're not interested in that price. You can just raise your hands. There's one person, Mark, online. Okay, oh, you're online twice. Okay, so we have 3 people. Okay, does anyone not want a JetBrains prize?
I don't really want
one. Okay, then you get a JetBrains prize, and then you 2 will get ebooks. So that's it. So make sure you get the info. You can, if you want, you can just give it to me after, but we do appreciate the feedback. So that we can So that's everything then.
Yes.
we will be meeting next month, right?
I do have that.
It's
Yes.
fine, but yes.
Yeah. Oh,
Our
and that's our topic. Look at
Our
that.
presenter is going to be online, but will we still come here? TBD.
Yeah, we'll post it in the meetup whether we'll be, for those of us who like to come down and be online. I'll actually be out of town, but my wife likes it when I come down here because I spend the entire rest of every day of every month at home bugging her. So she likes it because I come down and work at the WeWork all day and I'm gone all day. So she likes that. So if we meet in person, I won't be here for June, but I will be, if we can meet in person, I'll be here for July. So.
All right. We do meet the second Thursday of each month. So in June, that's June 11th. And the topic is, what if your AI could be a team? Chad Green, I don't know Chad Green, but Rob Richardson, one of our other board members, found him. Rob is like going to all these conferences, and he meets people that have, some good experience. So should be good.
Thank you very much.
Thanks.
I'm actually going downstairs. Okay.
Yeah. Right on.
Yeah, you've been here in the last couple of months, right? Yeah. And this is your first.
Yeah, probably not the last either. This is pretty.
So just so you know, this stuff is probably a little bit softer skills than most of our college. I can, but I think it's something.